Today, inshallah, we will solve February-March 2024. The first question is, which species contain the same number of neutrons as carbon-14 and the same number of electrons as nitrogen plus 1? In carbon-14, the number of neutrons equal 14 minus 6 equals 8. And in nitrogen plus 1, it contains 11 minus 1 equals 10 electrons. So we are searching for an element that contains 8 neutrons and 10 electrons. For F9, 17 minus 9, we have 8 neutrons, but the number of electrons is 9. For nitrogen minus 3, we have 16 minus 7, we have 9 neutrons and 10 electrons, so this is not the answer. For neon 10, we have 10 neutrons and 10 electrons, so this is not the answer. For oxygen 8, we have 8 neutrons and we have oxygen minus 2, it gained 2 electrons, so we have 10 electrons, so this is the answer. Okay? But in question number 2, we have which process has the largest enthalpy change per mole? طبعا all of them are ionization energies. All of them are ionization energies, and all of them are ionization energies in which you will remove an electron from a new shell. Okay? طيب, aluminum, phosphorus, sulfur, silicon, all of them exist in the same period. Aluminum. This is in period 3, aluminum, then silicon, then phosphorus, then sulfur. Okay? Aluminum 3, phosphorus 5, sulfur 6, silicon 4, all of them contain 2 shells. 2 shells. After, the starting ion has 2 shells. Okay, and we will remove the electron from the new shell, from the second shell. So all of them have the same, they have the same shielding effect. But sulfur is the smallest one, then phosphorus, then silicon, then aluminum, so it has the greatest charge density for sulfur, so it has the greatest attraction force, and it has the largest ionization energy. So the answer is C. Which sodium compounds contain 74.2% mass of sodium? In this case, I have to calculate the mass percentage of sodium in each one. So in the first one, to calculate the percentage of sodium, it will be طبعا sodium carbonate is Na2CO3. So it will be 2 times 23 divided by 23 times 2 plus 12 plus 16 times 3 times 100 equals 43.3%. The second one, sodium chloride, it's easy, so it will be 23 over 23 plus 35.5 times 100 equals 39.3. 39.3%. In sodium hydroxide, NaOH, it will be 23 over 23 plus 1 plus 16 times 100 equals 57.5%. And in the last one, sodium oxide, Na2O, so it will be 23 times 2 over 23 times 2 plus 16 times 100 equal 74 4 times 2%. So the answer is D, which is 74 times 2%. Right. Here, what is the maximum volume of sulfur dioxide gas? What is the maximum volume of sulfur dioxide gas made at room conditions produced when burning 100 decimeter cube of diesel fuel containing this amount of sulfur? Right. When we burn sulfur plus oxygen, it produces sulfur dioxide. Okay? So the number of moles between sulfur to sulfur dioxide is 1 to 1. So here the mass of sulfur is 0.8346. So the number of moles of sulfur equals 0.8346 over the molar mass of sulfur, which is 32.1, to change it to moles. This amount equal 0.8346 divided by 32.1 equal 0.026. So the number of moles of sulfur 0.026. So the number of moles of sulfur dioxide will be the same. This is the number of moles. Okay? Right. To change the number of moles of sulfur into volume, so the number of moles of sulfur, to change it to volume equal number of mole times 24 and change it to centimeter cube, so it will be 24,000. So the volume equals 0.026 times 24,000 equals 624 centimeter cube. Okay, so the answer is D, 624 centimeter cube. Right. Which row shows the correct number of covalent bond in the molecule of methyl propene? Methyl propene, we have here 1, 2, 3. This is propene. Methyl, so there is a methyl group connected to propene. CH, H, H, and here H, and here H, here H, here H, here H, and this is propene. So we have double bond here. Right. How many sigma bonds and how many pi bonds? Sigma bonds, it means single bond. And pi bond, it means double bond. Okay? So here, how many single bonds? To count the number of single bond, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're supposed to have also H here. So this one will be 11. Okay? And we have only one pi bond. So the answer is C, 11 sigma bond and 1 pi bond. Okay? Type. If we have for question 6, aluminum chloride exists as Al2O6 at room temperature. When heated under high temperature, AlCl3 is formed. What are the arrangements of the bonding pairs of electron around the aluminum atom in the two forms of aluminum? AlCl3, it is the same as BF3. So we will have Al in the middle, Cl, Cl, Cl. So the angle will be 120, 120, 120. So it will be planar, triagonal planar. And regarding Al2, regarding Al2O6, so it will be Al, Cl, 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 and here Al, Cl, Cl, Cl. Here we have dative covalent, and here we have dative covalent. So the shape in this case will be, because each aluminum atom surrounded by 4, since each aluminum atom surrounded by 4 chlorine atoms, so it looks like CH4, so it will be tetrahedral, so the answer is C. Sorry, the answer is B. Okay, because this one we said it's planar, and this one we said it's tetrahedral, so the answer is B. This one is tetrahedral. Okay. Type. The table shows the physical properties of 4 substances. Which substance has a giant covalent structure? Giant covalent structure This means that it has high melting and boiling points. Melting high, boiling high, so the answer could be C or D. It a poor conductor of solid, yes, its electrical conductivity poor, so the answer is D. Because the giant covalent structure is poor conductor in all cases, and it's insoluble in water. It's insoluble like diamond, it's insoluble in water, it doesn't conduct electricity when solid, it doesn't conduct electricity when liquid, and it has high melting and boiling point, so the answer is D. طيب, at room temperature and pressure, H2O is liquid and H2S is gas. Both of them are covalent. H2O and H2S, both of them are covalent. What's the reason for the difference in the state? Oxygen has higher first and second ionization energy than sulfur. Is this the reason why this one is liquid, this one is solid? No, there is no relation between the ionization energy and the state of the substance is related more to the intermolecular forces of attraction between the molecules. So the intermolecular forces that determine the state. The covalent bond between O and H is stronger than this one and this one. It doesn't relate to the state of the matter. There is significant hydrogen bond between H2O molecules, but not between H2S. Yes, this could be a reason because in H2O, O, H, we have O here is partial negative and H here is partial positive, here is partial negative, so we have a hydrogen bond here. But in H2S, we said that the only three elements that can make hydrogen bond in our syllabus are N, F, and O. These are the three elements that can make hydrogen bond. So there is hydrogen bond in H2O, yes. There is no hydrogen bond in H2O, H2S, yes. So the answer is C. Type. The enthalpy change for the reaction can be calculated from the enthalpy change of formation, the enthalpy change of combustion, the bond energies. The enthalpy change of this reaction given delta HBr. Type. The expression to calculate the enthalpy change, which expression could be used to calculate the enthalpy change? طبعا the enthalpy change delta H of the reaction, to make delta H of the reaction, it should be, we have to put here carbon dioxide plus water vapor, here 2 carbon dioxide, and here, 4 carbon dioxide, and here 6 H2O to balance. Then the arrows are down. In case of combustion, the arrows are down. Okay? So according to Hess's law, delta H of the reaction doesn't change whatever the root of the reaction. So this root is the same like this one. Okay? So here, delta H equals to delta H of combustion equal to 2 times equal to delta H combustion for C2H6. And here, since water is the same, carbon dioxide is the same, we don't have delta H for them, we have only 2 delta H for combustion of CH4. And here is delta H of the reaction. According to Hess's law, 2 delta H combustion of C2H6, no, ethane, equals delta H reaction plus 2 delta H combustion of CH4. So if you need to get the delta H of the reaction, so delta H of the reaction equal 2 delta H C2H6 minus 2 delta H combustion of CH4. So the answer is this one is wrong. 2 delta H C2H6 minus 2 delta H, so this one is right. So the answer is B. The answer is B because delta H of the reaction equal the delta H of propane 2 times the delta H of ethane minus 2 delta H of methane. Okay. Which reaction has the enthalpy change equal to the standard enthalpy change of formation of propane? Standard enthalpy change of formation is the enthalpy change when 1 mole of the compound is formed from its elements under standard states. And the element should be in its standard state. Propane is formed from carbon and hydrogen. The state of carbon is solid, the state of hydrogen is gas, and the state of propane is gas. So the answer is C, because here carbon is solid, hydrogen is gas, propane is gas. طبعا D is wrong because propane here is liquid. B is wrong because carbon is gas, and A is wrong also because carbon is gas. Okay. One of the reactions in the rechargeable lead acid battery is this one. Which statement is correct? Lead is both oxidized and reduced. So what is the oxidation state of lead here? It's 0. And the oxidation of state of lead here, it's +4, because oxygen minus 2 times 2 minus 4. So lead should be +4. Typed here, the oxidation state of lead here is +2 because sulfate is -2. And that's it. Here the oxidation state of hydrogen +1, oxygen -2, sulfur here is +6. Here sulfur is +6, oxygen -2, hydrogen +1, oxygen -2. So nothing changed except only lead. If we look at lead, from 0 to +2, it's oxidation. From +4 to +2, it's reduction. So yes, lead undergoes the process which we call it this proportionation, in which it undergoes oxidation and reduction. So the answer is A. طبعا neither oxidized or reduced wrong, oxidized only wrong, or reduced only wrong. طيب here KMnO4 is an oxidizing agent. Its reaction with Fe plus is shown in the following ionic equation. What is the value of X and Y? طب احنا we said before in to solve the redox equation, we should specify first which one oxidized, which one reduced, then put the number of electrons gained or lost, then try to balance the electron, then you can balance the equation. So here, manganese here is +7. Manganese here is +7, right? 7 plus. Iron here is +2. Manganese here is +2, and iron here is +3. Okay? So, manganese, to change from +7 to +2, so it should gain 5 electrons. And iron, to change from +2 to +3, it will lose 1 electron. To balance these two numbers of electrons, we have to multiply this one by 5 and this one by 1. So, manganese here, it should be, this one should be 1 and this one should be 1. And iron, this one should be 5 and this one should be 5. So X equals 1 and Y equals 5. So the answer is C. Nitrogen and the hydrogen are mixed in the reaction vessel. The reaction reaches equilibrium, giving a mixture of nitrogen, hydrogen, and ammonia. The mixture of gases present in equilibrium, the total pressure is 300. The total pressure, P total, is 300. The number of moles in the mixture is 180. In this question, what is the Kp? طبعا we know that Kp, the expression for the Kp equals the pressure of NH3 to the power of 2 over the pressure of N2 times the pressure of H2 to the power of 3. To the power of 3. طيب. Here I don't have the pressure of this one, I don't have the pressure of this one, I don't have the pressure of this one, but I have the total pressure. To get the pressure of each one of them, the pressure of each one of them equal the mole fraction times the total pressure. So I have to get the mole fraction of each one of them and multiply it by the total pressure. طيب. How do we get the mole fraction of NH3? I will get the mole fraction and multiply by the total pressure. The mole fraction equal the number of moles of the substance. Here the number of moles of ammonia is 160 over the total number of moles, which is this one plus this one plus this one, which is 160 plus 590 plus 180. This one times 300 equals 51.6129. 51.6129. The pressure of hydrogen equals the mole fraction of hydrogen, which is 590 over the total, which is 160 plus 590 plus 180 times 300 equals 190.32. 190.32. Okay, the pressure of nitrogen equals 180 divided by 160 plus 590 plus 180 times 300 equals 58. Equals 58. Equals 58. 58.00. Now I have the partial pressure of each one. I can get Kp. Kp equals pressure of NH3, which is 51.6129 square, divided by the pressure of N2, which is 58.00, times the pressure of hydrogen, which is 190.32 to the power of 3. When we calculate this, the answer will be 6.065 times 10 to the power of -6. Question number 14. Question number 14. A mixture of hydrogen gas and iodine gas is placed in the reaction vessel. Hydrogen gas and iodine gas, H2 and the I2, we put them in the reaction vessel. Of volume V, the volume of the vessel is V at the temperature T, the temperature is T. The reaction goes to equilibrium. So this is the reaction at equilibrium. All the substances remain in the gaseous state. All of them are gas. Argon gas is pumped into the reaction vessel. We put here argon, AR. Okay? The temperature in the vessel maintains T. How is the rate of the forward and backward reaction increase? Since we put something which is not related to the reactant or product, it doesn't change. It will not affect the rate of the reaction because we didn't increase the concentration of the reactant or the concentration of the product, or we didn't change the pressure. Okay, so the rate of the reaction is not affected The rate of the reaction is not affected. طيب. What about the partial pressure of each one? The partial pressure equal the mole fraction times the total pressure. طيب. When we add AR2, the mole fraction is not affected, the total pressure is not affected, so the number of moles of gases inside the vessel, it's the same, so it is not affected also. The total number of moles is the same, so it's not affected also. Okay? Type. The two experiments are carried out to study the reaction between zinc and sulfuric acid. Experiment number 1, small lumps added to excess dilute sulfuric acid. The reaction is carried out at lower temperature. Experiment number 2, the reaction carried out at lower temperature, though the reaction here is slow. By the way, here I have two factors, factor that increase the rate and factor that decrease the rate. Here I have factor that decreases the rate. Both experiments produce the same total volume of the gas. Here it produces the same total volume of the gas. So the total volume of the gas is the same, are completed in the same time. They complete in the same time and they have the same rate. Same time, it means same reaction rate. Since it produces the same total volume of the gas, it produces the same total volume of the gas. So this means that the concentration not increased. The concentration not increased. So if we add catalyst with the lower temperature is the factor that decreases the rate, catalyst is the factor that increases the rate. So, and it doesn't change the total volume of the gas, it will make the reaction go to the same time. So the answer is A. A greater mass of zinc will produce the total amount of gas produced. Greater volume of sulfuric acid if sulfuric acid is in excess, so it doesn't affect the rate in general. Larger lumps of zinc, we have low temperature, so it decreases the rate. If we put large lumps, it will also decrease the rate, so the reaction will not produce in the same time. It will take more time because the reaction will be slower than the first reaction in experiment number 2. It will be slower than experiment number 1, so it will not take the same time. Okay, so this is why if we want to make the reaction happen at lower temperature, we just as catalyst to increase the rate of the reaction, so it's finally ends at the same time. Okay, type question 16. The relative magnitude of the property X elements show P, Q, R, and S and T are all in period 3 and have consecutive atomic numbers. The letters are not the actual symbol of the elements. Which row is correct for the property X and R? Type. A, the property X is electrical conductivity. يعني if the property X is the electrical conductivity, R will be L. Type. If X is the electrical conductivity, if we start with sodium, magnesium, aluminum, phosphorus, silicon, phosphorus. So does aluminum will be the highest one? Yeah, yes, of course, the best conductor because it has the greatest number of free moving electrons. So the answer is A. Right? If it's electronegativity, no, the highest one in the electronegativity will be T in this case because it has the smallest radius. If it is the melting point, so the highest one will be Si. So here it will be not silicon. It should be something else. The second ionization energy Si, طبعا, of course, it's wrong. So the answer could be A. Element X in period 3. Element X in period 3. Element X react with oxygen to produce solid Y. So element X in period 3. It reacts with oxygen, so X plus oxygen, it gives XO, which is Y, and it is solid. Okay. When solid Y is added to water, a solution when pH is less than 7 is produced. Less than 7. So this oxide is acidic oxide. Acidic, and in the same time it's solid. So we are searching for non-metal that form oxide, which is solid, and of course it will be acidic. The non-metal, so we will cancel the metal because it gives basic oxide. We will cancel metalloid. Okay. Phosphorus and sulfur, both of them, when we react them with oxygen, phosphorus, it gives P4O10, which is oxide, acidic oxide, and SO2, which is acidic oxide. But this one is gas and this one is solid, so the answer is C. طيب. This equation refers to the isolated gaseous species. The species F negative, Ne, and Ne plus are isoelectronic. This means that they have the same number of electrons. So F negative has 10 electrons, Ne has 10 electrons, Na has 10 electrons. In which order do their radii increase? When the atom become positive ion, its radius decrease. When the atom become negative ion, so its radius increase, and when the atom stay as atom, its radius stay the same. So the one with the smallest atomic or ionic radii will be the positive ion. So the answer could be A or C. The second one is the normal atom, because the negative ion has greater radius. So the answer will be C, because this one is very small, this one is large, and this one between them. Okay? Right. Separate samples of magnesium and calcium are added to excess dilute sulfuric acid. The observations are summarized in the table. Magnesium, it's a vigorous reaction. Bubbles of gas produced, magnesium completely dissolved. Vigorous reaction with calcium, if we add it to sulfuric acid. Vigorous reaction with calcium, bubbles of gas are produced. The reaction soon stops and leave most of calcium unreacted. If we react magnesium with sulfuric acid, it gives magnesium sulfate plus water. And if we react calcium plus sulfuric acid, it gives calcium sulfate plus water. Why the reaction in case of magnesium continue? Because the product is magnesium sulfate. And here, why the reaction doesn't continue? Because as we go down, what happened to sulfate? As we go from magnesium, calcium, strontium, barium, as we go down, what happened to the solubility of sulfate? As we go down, the solubility of sulfate decreases. The solubility of sulfate decreases. So magnesium sulfate is more soluble, while calcium sulfate is less soluble. So the first reaction continue because magnesium sulfate, calcium is better oxidizing agent. Of course not, calcium is more reactive, so it's better reducing agent. Calcium is better reducing agent than magnesium. Yes, but this is not the reason also. Magnesium is more reactive metal. No, of course not. Magnesium sulfate is more soluble. Yes, it's right. So this is the reason, because magnesium sulfate dissolves, so it gives a chance for more magnesium to dissolve. But calcium, it's better reducing agent. It's more reactive, but once it's react, it forms calcium sulfate, which is not soluble. Anyway, dolomite. Question number 20. Dolomite soluble carbonate. Dolomite is a double carbonate, calcium magnesium carbonate, and it can be used instead of calcium carbonate for the treatment of acidic soil. The three statements are all refer to the agricultural use of these carbonates. Dolomite and calcium carbonate are both less soluble than calcium hydroxide. Of course, carbonates are insoluble in water أصلا. فالدولومايت والكربونate, right? Both of them are insoluble. 1 mole of dolomite has the same neutralizing effect of 1 mole of calcium carbonate. طيب calcium carbonate when it reacts it produces calcium oxide. When it reacts when it reacts with acid, it produces carbon dioxide. And the dolomite, when we react with acid, it produces also calcium oxide. How? So, in case of calcium carbonate, I have only 1 mole of calcium carbon dioxide. But in case of dolomite, I will have 2 moles of carbon dioxide. So, does it have the same, resulting in the same effect? Of course not. Of course not. Dolomite will have greater effect, neutralizing effect. So, this one is wrong. Okay, dolomite and calcium carbonate both increase the pH of the soil, of course, because both of them are base, so they will increase the pH of the soil. So the answer is 1 and 2 wrong, 2 and 3. The question about 2 salts, NaI and NaCl. The 2 solid salts are separately added to warm concentrated H2SO4, and the results noted. Aqueous solution of the 2 salts are separately added to silver nitrate and then concentrated ammonia. طيب احنا NaI when it reacts with sodium chloride it gives I, it gives H2S, it gives sulfur. NaCl when it reacts only it gives HCl, also it gives HI. Okay, so HI or NaCl, HI or HCl, when you add them to silver nitrate, it gives silver iodide and silver chloride. When we add aqueous nitrate, silver chloride is soluble, while silver iodide is insoluble. Okay? So, NaCl, it produces Cl2 طبعا. This is wrong. It doesn't produce because Cl is weaker reducing agent. The NaCl produces HCl, of course wrong. NaI produces HCS, yes. NaI produces I, yes. Both of them right. Right. Here, after adding this one and this one, the solution is colorless. In case of NaI, we said the solution is not colorless, it's insoluble. So it gives yellow precipitate that doesn't dissolve. We remember that AgI, it gives yellow precipitate, but this AgBr, it gives white precipitate. So it is not colorless, it's yellow precipitate, it doesn't dissolve. Okay? طيب. The diagram shows the process of adding calcium nitrate and strontium nitrate to separate the boiling tubes and heating them in identical conditions are used. Calcium nitrate, water containing universal indicator. The calcium nitrate when we heat it. Calcium nitrate when we heat it, it produces calcium oxide plus nitrogen dioxide plus oxygen. 2, 2, 4 for balance. Okay? Here, strontium nitrate, when we heat it, it produces strontium oxide plus nitrogen dioxide plus oxygen, and also 2, 2, 4 for balance. طيب. As the reaction proceeds, the water containing universal indicator changes the color. طبعا the water changes the color because this gas, which is acidic gas, will produce, right? Acidic gas will produce. Right. Which will describe the color change and identifies the nitrate that causes the quickest color change. طبعا the quickest color change, it means that it will be thermally decomposed first. But which one is more stable? This one is more stable. This one is less stable. So this one will be decomposed first. Okay. طيب, the color of the universal indicator, in water it's green. The acidic gas, when it passes through it, it make it red. So green to red. So the answer is C or D. And the CaCO3, it decomposes faster because it's less stable. Nitrates. So because we know that the nitrates, as we go down, the thermal stability increase. The thermal stability increase as we down in the grade. Okay. طيب. The equations for the three reactions involving chlorine or its compounds are listed. KClO3, KCl plus 3O2. KClO3 gives KClO4 plus KCl and KOH plus 3Cl2 gives 3H2O plus KCl plus KClO3. Which statement about these equations are correct? Equation 1 describes the formation of compound used to kill bacteria. طبعا the compound used to kill bacteria is ClO negative. Whatever بقى CHClO or ClO. This one doesn't exist in equation 1, so it's wrong. Equation 1 doesn't represent a redox reaction. Here the oxidation state of chlorine is plus 5. And here the oxidation state of chlorine is plus 7, and here minus 1. So it's a redox reaction because chlorine increases and decreases. Here the oxidation state of chlorine is 0. Here the oxidation state of chlorine is minus 1, and here it's plus 5. So equation 1 doesn't represent a redox reaction, wrong. Sorry, equation 1 here, the oxidation state here is plus 5, here minus 1, and the oxygen here minus 2, and the oxygen here is 0. So chlorine decrease and oxygen increase, so it's redox reaction. Equation 2 describes the formation of potassium chlorate 5. No, طبعا it's not potassium chlorate 5, it's potassium chlorate 7. So it's wrong. Equation 2 and 3 both represent disproportionation. 2 and 3, here the oxidation and reduction only happen for Cl, so it's right. Nitrogen monoxide NO is primary pollutant produced by petrol engine and is found in the exhaust gases. Which reaction occur in the catalytic converter decrease the emission of nitrogen gas? طبعا in the catalytic converter we don't get carbon, we don't get carbon monoxide, we get carbon dioxide and nitrogen, right? And nitrogen oxide react with carbon monoxide. Yes, this is happening in the catalytic converter. We said that in the catalytic converter, there is a very smart way to reduce, to eliminate both nitrogen oxide and carbon monoxide by the same way, in the same step, which is addition of nitrogen monoxide to carbon monoxide. Okay, طبعا we didn't get carbon solid, it will be a great problem. But here, 25, the diagram shows the structure of naturally occurring molecule cholesterol. Student X stated that 17 carbon atoms in the 4 rings are all in the same plane. Student Y states that his molecule displays cis-trans isomerism at the double bond. Which one is correct? The first one is stay in the same plane. This is wrong because we have double bond. If we don't have double bond, they will be. But since we have double bond, so it is wrong. Since we have double bond, so Y is wrong. State that displays cis-trans. So yes, we have double bond. Yes, but this carbon contain H here and another R group here. So yes, and here this group is different than this group, so it represents the cis-trans isomer. So the answer is the student Y only is correct. The drug cortisone, be careful about the drug cortisone and cholesterol because it came a couple of times in the exam. Cortisone has the formula, this formula. In addition to those chiral centers marked by the asterisk, how many other chiral centers are present? Type. We said that there is no chiral center for any compound, for any carbon that is connected to 2 hydrogen atoms or any carbon that makes a double bond. These 2 carbons are not chiral. Here, not chiral, not chiral, not chiral, not chiral, not chiral. I think this one is chiral. This one is chiral because we have here methyl group. We have here CH3 group. This one, this one, this one, this one are different, so it's chiral. Okay. This one not chiral, not chiral, not chiral. This one is chiral. This one is chiral, and this one also chiral because it has different 4 different groups. 4 different groups. This one is not chiral. This one is not chiral. This one is not chiral carbon atom. Okay, so we have, rather than these carbons, we have 1, 2, 3 chiral carbon atoms. Number 27, butene reactors called diluted acidified 1, 2, 3, 4. Butene reactors called acidified KMnO4 to give X. طبعا called acidified KMnO4 it gives alcohol. Okay, carbon, and it reacts with hot concentrated acidified butene. It gives carboxylic acid, right? Here methyl, and here H. Here methyl, and here H. So it gives carboxylic acid. So which statement produce X and Y about X and product X and product Y is correct? Both X and Y will react with 2,4. طبعا 2,4-DNPH 2,4-DNPH only affect carbonyl group, whatever an aldehyde or ketone. So since we don't have aldehyde or ketone, so both of them, they don't react. Neither product Y or X doesn't react, right? Neither of them, product X will react, Y will not react, no. And product Y will react, product X is not, it's not the right answer. Okay, type question 28. Aqueous reaction, a sequence of reactions takes place. The major product is compound Z. Type propanoic acid, this is a strong reducing agent. It gives alcohol. This alcohol will be primary alcohol because it's propanoic acid. Type. When we put concentrated H2SO4, it makes an elimination reaction to form alkene, propene. This propene, when we pass it with the steam over H3PO4, propene, the double bond will be broken and OH will be added here. Because this carbon contains less number of hydrogens, so it will take OH, and the H will be moved to the other carbon. So in this case, we will have 2 propanol. So compound Z is propane 2-ol or 2-propanol. Okay. Number 29, which statement is correct? Bromo ethane react with sodium hydroxide to form bromoethane is bromoethane يعني C2H5Br. طبعا this is primary halogen alkane. React with sodium hydroxide to form ethene as the major product. Of course not. It form ethanol. Form ethanol. One chloroethane react more rapidly than one bromomethane. Of course not, because we said that CCl, CBr, CICF. As we go down, the halogenoalkane will be more reactive because the bond will be weaker and it will be easier to be broken. So CBr, this one react faster than this one. Hydrolysis of C2H5 occurs mostly by SN two mechanisms. This is tertiary hydrocarbon, so it reacts only by primary SN1 mechanism. This is tertiary, and SN2 for primary. This one, this carbocation CH3, CH2, CH2 plus ion, is less stable than this one, of course, because this one is tertiary carbocation, and we said that the tertiary carbocation is more stable because these three methyl group are electron donating, so it has more positive inductive effect. So D is right. Question 30. In the electrolysis of bromo ethane by aqueous sodium hydroxide. Bromoethane by bromoethane 1, 2, H, H, Br, H, H, H. Bromo by aqueous NaOH. Aqueous NaOH introducing OH to the group, so it will attack this one, so this one will be eliminated. Type. What is the nature of attacking group and the leaving group? The attacking group here is OH, and the leaving group here is Br. Br negative. Type. The attacking group electrophile, of course not. The attacking group should be nucleophile, and the leaving, both of them nucleophile. This one nucleophile and this one nucleophile, so the answer is D. Okay? X is an organic compound containing elements carbon, hydrogen, and oxygen only. The table shows the observation made from 3 chemical tests carried out on X. So X is an organic compound containing element carbon, hydrogen, and oxygen only. It doesn't contain nitrogen. The table shows the observation when the 3 chemicals test carried out on X. It reacts with sodium, so it could be alcohol or carboxylic acid. We put this one sodium carbonate effervescence, so it contains carboxylic acid. طيب. Hot potassium dichromate doesn't change. It remain unchanged. So alcohol. So sure, carboxylic acid group exists. So sure, the compound has COH type. OH. The alcohol group, since here it doesn't give any result with this potassium dichromate, so either OH doesn't exist or OH exists in tertiary carbon atom. In both cases, it will not give a result with this one, with the potassium dichromate. So if we look at the first one, طبعا it contains COH, and this OH is secondary, so it couldn't be the answer. طبعا all of them contain OH, so OH should be tertiary in this case. Okay, here OH is secondary, here OH is tertiary, right? But the compound doesn't contain COOH, so it's not the answer. So the answer is D because it contains carboxylic group, and in the same time, this OH is tertiary carbon atom. How many moles of oxygen atom needed to complete combustion of CH3 3COH? CH3 by 3COH. When it reacts with oxygen, it produces complete combustion, produces CO2 plus H2O. Type. Let's balance this equation. When we balance this equation here, I have C3 plus carbon, so we have 4 carbons, okay? And hydrogens, we have 3 times 3, 9 plus 1, 10, so we have 5 hydrogens, right? Now, since we have 5 hydrogens, so 4 times 2, 8 oxygen, and 5 times 1 plus 5 oxygen equal 13 oxygen. Since we have 1 oxygen here, so this one should be 12 oxygen, so we should put 6 here to be 12. So the answer is 6. Okay? Type. In which pair will each compound give a different visible result. Different visible result with aqueous alkaline. طبعا we know that aqueous أو alkaline triiodomethane test, it gives positive result if the compound contains CH3 C double bond O, or if it contains CH3 CHOH. It gives, or CH3, of course, COH. If the compound is ketone or alcohol or aldehyde contain this group or this group or this group at the beginning, so it gives a positive result. At the beginning, this one gives positive results, and this one also gives positive results. So there is no different visible results. This one, both of them, CH3CO, CH3CO, both of them give results because both of them contain the groups. This one doesn't give visible results because it's carboxylic acid, and this one also doesn't give visible results because it's it doesn't contain CH3CO at the beginning. Okay, this is pentanone. It doesn't contain. This one, it gives a positive result, and this one, it doesn't give positive results. So D gives two different results because this one contains this group at the beginning, but this one doesn't contain the methyl ketone group at the beginning. Okay? Right, which reagent gives a positive result with propanol? Right, propanol is ketone. Which one gives a positive result with ketone? طبعا alkaline, this one gives a positive result with propanol because propanol contains CH3CO, CH3. It contains CH3CO at the beginning, so it gives a positive result. طبعا aqueous bromine doesn't give because it doesn't contain double bond. Valine, it doesn't give because valine and toluene, both of them doesn't give because it's not aldehyde. Aldehyde, يعني it doesn't contain CHO group. Okay? طيب, esters can be hydrolyzed with an aqueous alkali or an aqueous acid to form a product. Esters can be hydrolyzed by aqueous alkali or aqueous acid. طبعا with aqueous alkali, ester gives salt plus alcohol. With acid, it gives carboxylic acid plus alcohol. So with aqueous alkali, complete conversion to salt and organic acid, wrong. Form an equilibrium mixture of salt and organic acid, wrong. Complete conversion to salt and alcohol, okay. Complete conversion to salt and alcohol, both of them right till now. Form equilibrium mixture with organic acid and alcohol. Complete conversion, no, it's not complete conversion because you know the esterification reaction is a reversible reaction. When we have a carboxylic acid plus alcohol give ester plus water, this reaction is reversible, and this is why to make this reaction happen in one way we add concentrated sulfuric acid. So it's not a complete conversion for alcohol and carboxylic acid because the reaction is reversible. So the reaction reaches equilibrium, and the answer is C. Structural isomerism. Structural isomerism should be considered when answering this question. How many compounds with the molecular formula C5 C5H11Br? So C5 يعني 1 2 3 4 5. Okay? Type. We can put BR here, it will be 1. We can put BR here, it will be 2. We can put BR here, it will be 3. So till now we have 3. Or we can add one of the methyl groups here, and we put primary. We need primary halogenoalkane. So this one is not primary halogenoalkane. Type. We can have this one. This one is a primary halogenoalkane. We can make like this and put BR here. It could be primary halogenoalkane. Or we put it here. It could be primary halogenoalkane. So we have till now 3. Or we can put it here and it will be a primary halogen alkane. So totally we have 4. 1, 2, 3, 4. Okay. In all of these cases, it will be primary halogenoalkane. Type. Compound Z is formed by the reaction scheme shown. CH3Br, KCN, ethanol, it gives CH3CH2CN, gives CH3CH2CN. With dilute acid, we said that nitrile with acid, it becomes carboxylic acid, so it becomes CH3CH2COOH in the presence of acid. وطبعا in the presence of in the reduction, or in the presence of if we reduce it, it gives CH3CH2CH2NH2. It gives amine. So the answer is D. The answer is D. 38. Hydroxyethanol is heated under flux with excess acidified manganate until no further change. Here we have aldehyde and we have alcohol group. Aldehyde, if we heat it with dichromate or potassium manganate, it becomes COOH. And the alcohol, when we heat it, it becomes also COOH when we oxidize it. So the reaction, it gives finally C here OOH because of the aldehyde, and here OOH because of the alcohol. So the answer is, we have only 2 carbon atoms. So this one is wrong. It has 3 carbon atoms. This one is, we have 2 carbon atoms here. Yes, this one is right. This one is wrong because it doesn't stay in alcohol, and this one is wrong because we don't have a ketone group. Okay, this one then. The formula shows the repeat unit of addition polymers. This addition polymer CH3 CH2CH3. This is a repeat unit of the addition polymer. What is the name of the monomer? To find the monomer, we just remove this bond and remove this bond and return the double bond here. So what is the name of this compound? This compound consists of 1, 2, 3, 4, 5 carbons. So it's pent. Double bond exists between carbon number 2 and 3, so it's pent2ene. So the name is pent2ene. Okay? Question number 40. The infrared spectrum of the compound is shown, the transmittance and the wave numbers. We just care about the peaks, the long peaks, and forget about the short peaks. Now you just care about the long peaks. This peak for 3000 is for OH, right? It's for OH of alcohol. Instead, the infrared spectrum, this is for OH of alcohol. This peak is mainly for C double bond O at 1700, and this peak for at 1000, 100, 200, 300, 1150. It's for CO, C single bond O. Okay. Which functional group could be contained? We have CO, we have C single bond O, and do we have OH? This OH alcohol, this OH for hydroxy for alcohol. We don't have alcohol because we have CO and COH. And since we have CO, if we have OH in addition to CO, so it will be carboxylic group, and it will be it will have a wide peak at this OH. We don't have here wide peak, so it's not an alcohol. Okay, so this compound doesn't contain OH. It just contains C double bond O and C single bond O. C double bond O and C single bond O. It doesn't exist in this one, only OH. This one carboxylic acid, it doesn't consist of, because if this one exists, it will give here a wide peak. This one is ester. Ester contains C double bond O. O. Yes, right. This is ester because it gives C double bond O. O. And nitrile. Nitrile, it gives C triple bond N at this. And we don't have peak at 250. We don't have peak here. We don't have peak here, so we don't have nitrile. So the answer is C. And this was the last question in this exam. 970112 February, March 24. Thank you.